Assalamualaikum everyone. Assalamualaikum. Yes, am I audible to everyone?
Sir.
Okay. So okay. So let's start with question number 1. Hydrated magnesium sulfate has the formula of MgSO4X4. Yes, everyone. When hydrated magnesium sulfate is heated, so we have started question number 1. Here we have heating the hydrated magnesium sulfate, which contains the water of crystallization, and on heating that water is removed as a water vapors from the salt, and only anhydrous salt is left with no water. Okay. A student does an experiment to find the value of X in magnesium sulfate .xH2O. The student records the mass of crucible, adds hydrated magnesium sulfate to the crucible, and records the mass again. So here we are just getting the mass of container only, and here we are getting the mass of container along with the mass of magnesium sulfate that is hydrated. Then heats the crucible strongly, allows the crucible and the content to cool, and record the mass again. Repeat 3 and 4 until the same mass is recorded. So we get same mass, then that is the mass of crucible plus magnesium sulfate mass only. All the water must be lost in that case. Now, in the 6th stage, uses the results to calculate the initial mass of magnesium sulfate .xH2O and the final mass of magnesium sulfate. Suggest why a crucible is used instead of glass beaker. Yes, you have to identify why we have used crucible instead of glass beaker.
Sir, because in crucible we can heat.
Sorry, can you repeat?
So we use crucible to heat.
Yes, and we have to do it strong heating, right? For a gentle heating, we can use a glass beaker or a test tube. But here, for a strong heating, we need a crucible because glass beaker may break. Okay. So the reason over here, you can write that the glass beaker may break. Okay. Now, then suggest why 3 and 4 are repeated until the same mass is recorded twice. It is because we have to remove all the water from the hydrated salt. So when we are getting the same mass after heating, and then we are again getting the same mass after heating again, it clearly indicates that whatever the water was there, all must have lost. So here we will write to ensure that all the water is removed. Is this clear to everyone? Yes.
Yes, sir, clear.
Okay. B. Several students do the same experiment with a different initial masses of magnesium sulfate .xh2o. The results are shown in the table. Okay. First, what they are saying. Complete the table. Okay. So subtract these two and tell me the answer, please. And here you have to do the subtraction again. Here you are getting 1.04. Yes, can anybody tell me the answer over here? Minus 5 gives you 7. And 4 minus 2 gives you 2. Okay, 0.27. Is this clear?
Yes, sir.
Okay. Now, on the grid, plot the final mass of magnesium sulfate against the mass of water lost. Okay. It means we have to plot these two values. So when the final mass is 0.25, for the first one, the final mass is 0.25 and the mass of water lost is 0.27. So 0.25 must be this one because here it's 0.30. And this is 0.30. So I have to figure it out. 0.27. It must be over here, which means, and remember, always put a cross. Okay. So this is the point over here. Then 0.50 and 0.48. Okay, 0.50 is over here and 0.48. So 0.48 would be over here. Then we have 0.67 and 0.83. Oh, 1 minute. 0.48 and 0.50. So here it is 0.50 and 0.48. So it must be over here. Okay. Then the next value is 0.83 of magnesium sulfate and 0.67 of water. So 0.83, 0.9, 0.83, and on 0.83 we need a 0.67. So Here it's 0.60. Okay, I think I'm doing something wrong. If you see, here it is a mass of water, and here it's magnesium sulfate. Yes. So 0.25 is of magnesium sulfate and 0.27 is of water. So 0.27 would be over here, and 0.25 would be over here. Then 0.50 and 0.48. So 0.50 would be over here, and for 0.48 it would be over here. Then 0.67 and 0.83. So 0.67 would be over here, and 0.83 it's 3.5, 0.8, 0.82 and 0.83. Yeah, it would be over here. Then 1.04 and 1. 1.04 and 1. So it is over here. And then 1.30 and 1.23. So 1.30 and 1.23. 1.23 would be here. And then 1.53 and 1.46. So 1.53 and 1.46 would be over here. Is this understandable? They have asked you to plot the final masses against this, and they didn't ask you to draw the line. So there is no need to draw any curve or a line over here. Okay. Is this clear? Yes.
Yes.
हम line of best fit नहीं draw करें.
No, if see on plot the and yeah. But see, here there is no instruction of drawing a line, right? They have just asked you to plot the final mass against this. So we have did this. If the examiner asks us, then we would do. See, here it is saying in the fifth part. So we have to draw a circle around the anomalous result on your graph. So our anomalous result would be this one, because see, it is going out of the line of best fit, right? Then suggest a reason for the anomalous result. Yes, can anybody suggest the reason? So let me explain it to you that for see, the mass of magnesium that we are getting is, for example, it's this. But in actually, if you see the course of the line, then you can figure it out. It would be, instead of this, it must be over here. So the actual mass would be lower. It could be, for example, 0.70, and instead we are getting 0.82, for example. So the actual mass would be lower, but we are getting the greater mass of magnesium sulfate, which is clearly indicating that all of the water must not be evaporated. Is this clear? So it is indicating us that actually the mass would be over here where I have put a point, but instead it is greater than that one, which is clearly indicating so the reason would be that the sample is not treated to the constant mass, or instead you can write that there must be some water in it. Is this clear?
Yes, sir.
Now, now we have to draw the line of best fit. So I don't know what is happening over here, but you can match all the points, okay? Next part. In another experiment, the final mass of magnesium sulfate is 1.20 gram. Use your graph to determine the mass of water lost. So I have to make the correct line. Let me try it again. Let me keep it like this. So if the final mass of magnesium is 1.2, then The mass of water lost is 1.26. Is this clear to everyone? Yes.
Yes, sir.
Now, next part. Calculate the number of moles of water in your answer to 1. Okay. So if it would be easy that moles of water must be equal to 1.26 divided by 18. It's MR. So can anybody tell me the answer?
So 0.07.
0.07.
0.07 moles. Okay. Then 1.20 gram magnesium sulfate contains 0.01 mole of magnesium sulfate. Calculate the value of X in magnesium sulfate. Okay, so this moles are actually lost when the final mass of magnesium sulfate left was 1.2. So we can easily relate these two. So when we relate it, that magnesium sulfate is to water, that 0.01 moles of magnesium sulfate are there, then the water lost is 0.07 moles. So if there is a 1 mole, then the water must be X. So if you will find the value of X, it would be 0.07 divided by 0.01, which will give you 7. So the value of X would be 7. Is this clear? So in this formula, the X is basically 7. So magnesium sulfate dot 7H2O. Is this understandable to everyone?
Yes, sir.
Yes. Sir, in part B part 4, can we also write the sample wasn't heated enough? Sir, ये लिख सकते हैं क्या?
Can you repeat?
Sir, B के part 4 में सिर्फ ये लिख सकते हैं कि the sample wasn't heated enough.
Here.
In B
You're
part
talking
4.
about this thing?
Yes.
In B
Constant mass लिखना जरूरी है क्या?
4. Yes, you can write that the sample is not heated enough. I think
ठीक है
you
sir.
can write enough. Okay. Okay, now for this, a solution contains 2 different cations and 1 anion. We will name any gases formed and describe the test used to identify these gases. For this, now you are going to provide it with the tables at the end of the paper, so you can take the help from that. Okay, while attempting the question like this. So what did it? Add aqueous sodium hydroxide to the solution in a boiling tube. A pale green precipitate forms. So let me recall you, if the precipitates are pale green, so it can be a chromium ion or it can be a iron 2 positive ion. You can check it from the table of the test for cations and anions that would be provided to you in the exam. Now, part 1. To the same boiling tube, continue adding aqueous sodium hydroxide until in excess. A green precipitate dissolves to form a green solution. If this is so, then chromium ions is confirmed and there is no iron ions, because if there is an iron 2 positive ion, then the precipitate doesn't dissolve to give you a green solution. Instead, the precipitate remains insoluble. So from this, I can conclude that the cation is chromium 3 positive ion. Is this clear? And then they said that a white precipitate remains. So it means there is a white precipitate as well, and it remains insoluble, which clearly indicates that these white precipitates are of calcium 2 positive ion. Is this understandable to everyone? Yes.
Yeah.
Okay. Now what they are saying, keep the contents of the boiling tube for test 2. Okay. And test 2, the salt that we are getting, the anion we are getting is a nitrate ion. So if you check the test for the nitrate ion, that test suggests that we have to add aqueous sodium hydroxide and aluminium foil and heat it. The observation would be ammonia gas forms, or instead writing ammonia gas, you would write that gas is evolved over here in the observation, and then in the conclusion it's as it turns damp red litmus blue. Is this clear?
Sir,
Yeah.
sir, IGCSE के पेपर में टेस्ट ऑफ cations और anions दिए हुए होते हैं.
Yes, that's what I have told you. In O levels, they are also provided you at the end of the paper now. So you have to check these from there and put it the answer over here. Okay.
Yes, sir.
Be provided to all of you. Okay. Now B part. Ammonium sulfide is a water soluble compound and its formula is NH4 2iSO3. Aqueous ammonium sulfide is slowly oxidized by oxygen in air. This means aqueous ammonium sulfide will also contain some sulfate ions. So it means that the solution have both sulfite ions and sulfate ions, because some of the sulfite ions are actually oxidized to sulfate due to the interaction with air. And specifically with the describe a series of tests and the observations to show the presence of ammonium ions, sulfite ions, and sulfate ions in this solution. It must be clear in your answer which ion is identified by each test. Okay, so you have to do for each one of them, ammonium ion, sulfate ion, and sulfite ion. So let's start with subcation ammonium ion. So first you would mention that which test you are going to show. So for ammonium ions, add aqueous sodium hydroxide and warm the solution. Okay. A gas evolved which is ammonia and it turns damp red litmus blue. Is this understandable? Further, you mentioned that if ammonium is present, so there is an ammonium. So no, there is no need because we know that there is ammonium. Now, for add acid and warm the solution. Sulfur dioxide gas evolve, which turns acidified potassium magnate 7. Instead of writing the whole name, you would write it like this as well. Purple to colorless. Now, for sulfate ions, add aqueous barium nitrate, and for that you don't need to remember because these all the tests are mentioned, are provided to you at the end of the end pages. And dilute nitric acid as well. White precipitate form. Is this understandable to everyone? If you have confusion, you would answer
Sir.
the question.
Yes.
Okay. Now, a titration method can be used to make soluble salts. Okay. A experiment to prepare a pure sample of sodium chloride. Part of the method is shown in the diagram. Okay. In step 1, the student uses a measuring cylinder to add 25 centimeter cube of aqueous sodium hydroxide to the conical flask. State how the accuracy of this experiment could be improved in step 1. Yes, how normally we add the first reagent in the conical flask with which apparatus?
Pipette.
Very good. So use pipette instead of measuring cylinder. Right? Now, describe what the student does in step 2 of the method. So they have labeled two things, B and A, and it's of 3 marks, right? So if we have added the sodium hydroxide in step 1 in the conical flask, then in step 2, that B is, and they have said that include the names of apparatus A and solution B. Okay, so B is hydrochloric acid, and A is burette, burette is filled with hydrochloric acid and the initial volume is recorded. That is very important, to record the initial volume before starting the titration. Is this understandable to everyone? Yes?
Yes, sir.
Okay. Now, in C, identify what is added to flask in step 3 before starting the titration. So if you see, yes, what would we have to add over here? Yes, can anyone? Before starting the titration? Sorry?
Indicator.
Yes, we would add indicator. Now, in step 4, the student adds solution B to the aqueous solution sodium hydroxide in a conical flask until the end point is reached. The student recorded the volume of solution B added. State how the student knows when the end point is reached. So
The
how
color
could we know?
Color
The
changes.
color changes. Yeah, very good.
Color change.
Color changes. Now, the rest of the method involves adding the recorded volume of solution B to another 25 centimeter cube of aqueous sodium hydroxide. The substance added in step 3 of the first titration is not added. Suggest why this substance is not added. We have added the indicator, and indicator actually, when the indicator is added and we have reached the end point, we get the salt and the indicator both in the solution. So it is a contaminated solution, or it is a mixture of a solution. We are not getting the pure salt. Okay. So to get the pure salt, or you can write to avoid contamination. Is this understandable?
Yes.
Okay. Now, describe how the student obtained pure crystals of sodium chloride from the solution in the conical flask. And see, it's of 3 mark. So whenever they ask you to obtain the crystals from the solution, so first you will write heat the solution to the crystallization point. Allow to cool. On cooling, remove the crystals and dry them using filter paper. Is this understandable to everyone?
Yes, sir.
Yes.
Okay. Now we have to start question number 4. A student oxidizes a sample of ethanol. Some of the apparatus the student uses is shown. Okay. Name the three pieces of apparatus. Okay. So what is P?
Condensation tube.
P is called Liebig condenser.
Condenser. Yeah.
Q is called round bottom flask. And R is funnel. Then the student transfers 25 centimeter cube of ethanol into the apparatus Q, adds an oxidizing agent, assembles the apparatus as shown. Okay. So the condenser is placed in a vertical displacement. Heats apparatus Q gently
Huh?
till all the oxidizing agent has changed color. Yes.
Sir, for the apparatus P, can we call it a condensation tube instead of Liebig condenser? Will that be accepted?
No, you must say Liebig condenser because its proper name is Liebig condenser.
Okay.
Name a suitable piece of apparatus to measure 25 centimeter cube of ethanol. So
Pipette.
it's a 25 centimeter cube. Yes, very good, Hassan. It's a pipette. Or instead pipette, you can use a burette as well. Okay. Pipette. Or you can use burette as well. Name a suitable oxidizing agent. So we have discussed so many times. And it's of 2 marks. So you must write acidified if you just write potassium magnate 7, then you would be going to get only 1 mark. So you must have to write acidified potassium magnate. State the color change that would be seen with this oxidizing agent. So it's initially purple and then yeah,
Colorless.
purple to colorless. Suggest a reason for placing apparatus P vertically. Yes, can anybody suggest? Because if we are continuously heating, the vapors must evaporate, and when they evaporate, they can be escaped. So the condenser is in a vertical displacement. So here in this region, these vapors are going to be condensed and then drop back for the further reaction or for the completion of the reaction. So it prevents vapors from escaping. Next part. After all the oxidizing agent reacts, apparatus Q contains a mixture of ethanol, water, and product of the oxidation. Name the product of the oxidation. If it's an ethanol and when ethanol oxidizes, what would we get? Yes, ethanol oxidizes. It's an alcohol. Alcohol always oxidizes to a carboxylic acid. So hence it's an ethanol. So it will be ethanol acid. Next, name the process used to separate the 3 liquids in the apparatus Q. There are 3 liquids. So what we would do? We would do fractional distillation. If there are 2 or more liquids in a solution, then those can be separated by fractional distillation only. State why this process is suitable. you should refer to the physical property of this liquid, of the liquids. So these liquids have different okay. Is this clear to everyone? Yes, is it clear?
Yes, sir.
Yes, sir.
Okay. Now we are left with question number 5. I think we can do it right now. Just give me 2 minutes, please. Okay, let's do the last question. The apparatus shown is used to compare the rates of the reaction of different metals with hydrochloric acid. Okay. Here we have the apparatus. The metals used and the mass of each are shown. Okay. And we have used 50 centimeter cube of 0.1 mole per dm cube hydrochloric acid, which means it's a concentration and it's a volume. Okay. Here we have a method. The student places a sample of one of the metals in the small tube. Okay, you are observing the tube. Transfer 50 centimeter cube of 0.1 mole per dm cube hydrochloric acid into a conical flask. Places the small tube into the apparatus as shown in the diagram. Tips the flask so that the small tube falls over and the metal and the acid comes in contact. Start a timer. Okay. Record the total volume of a gas formed at regular time intervals until the reaction finishes. Repeat the method with each metal. Okay. Now what they are asking, name an alternative piece of apparatus that could be used instead of the measuring cylinder to collect the gas and measuring its volume.
Syringe.
Yes. Yes.
Gas syringe.
Yeah, very good. It's a gas syringe. We can use gas syringe over here. Now, the gas collected in the measuring cylinder is hydrogen. Give a test and its result to show this gas is hydrogen. So I think you all must remember the test.
Lighted splint.
Yeah, burning splint or a lighted splint. And the observation would be a pop sound.
So we can write squeaky pop sound.
Yeah, you can write that as well. Another student thinks it would be easier to remove the bung from the flask, add the metal directly to the acid, and then replace the. State 2 disadvantages of this method. Yes.
It is more dangerous.
Okay, beside this, isn't it, if we putting the metal and then we are placing the bung, so gas, the hydrogen that is formed, it can be skipped from there, right? So the hydrogen gas formed can escape only obviously a little amount. So if we press the bung to close it, then the air that is over here would be moved towards, the measuring cylinder. So we are not going to get the exact volume of hydrogen that is formed. So we can write that bung will displace the gas into measuring cylinder a graph representing the result is shown. Give the correct labels for each axis through the graph. Each axis of the graph. Okay. So if you recall, on x-axis, whenever we have plotted the graph for the rate, to find the rate, on x-axis we always keep the time, and as on y-axis it is getting increased and then flattened, which means that on y-axis there must be a volume of a hydrogen gas or volume of gas. So whenever you are writing these, you have to mention in the units as well, because in the exercises we always do mention the units. Okay, now see part 2. It starts steep, gradually levels off. See, it's the steepest, right? So we can say that rate of the reaction is, it's of 3 marks, so we have to cover 3 points. Is fastest, as it's steep, gradually levels off means that reaction slows down and becomes horizontal, means reaction is stopped. Is this understandable to everyone? Yes?
Yes, sir.
Now, identify which of the metal gives each of the curves A, B, C, and D. Okay. So it also, if you see it based on the reactivity. So if you order, so calcium must be a most reactive one. Then we have a magnesium. Then we have a zinc, and then we have a iron. This is of calcium. B is more steeper, so more less steeper, so it would be zinc. And D have a very less steep, it must be iron. Is this clear? Yes, clear.
So have they given the options? We're just writing them.
To everyone. Yes, is this clear?
Yes, sir.
Yes, sir.
So these we can predicted identify the element also helped us. Now, what they are saying in the fourth part, different masses of each metal are used for experiment. State three variables that must be kept constant for the experiment. Okay, so if we are just going to change, going to observe the rate with different masses, so it means that
So temperature?
yeah, very good. Temperature must be kept constant, and the metals are solid. So the surface
Mass.
area of solid. No, see the different masses are used. They have mentioned you. So surface area of metals, and we are reacting the metal with the acid. So the concentration of an acid must be the same or must be kept constant. Is this clear? Yes.
So can we write volume of acid?
But concentration is more significant.
Okay.
Suggest why different masses of each metal are used for the experiment. So that is the only possibility, because each metal have a different relative atomic mass. So if we are using the different masses, so their volume must, so the number of moles that we are getting must be same. If you want to verify, do it, divide its calcium, mass of calcium with its AR. Iron is 56, magnesium is 24, and zinc is I don't remember its AR. So you and divide it by AR, you will get the number of moles, and I think each one have a same moles. So that's why we have used the different masses, so we would get the same number of moles. Okay. Is this clear?
Yes, sir.
Same number of moles of each element. Okay. So here we have completed the paper, and inshallah tomorrow we will be starting another paper, and we will do the paper. I will share the timings for tomorrow, inshallah, as soon as possible, tonight or in the morning. Okay. See you everyone. Take care. Goodbye. Allah
Thank you,
Hafiz.
sir. Allah Hafiz.
Allah Hafiz.